Electromagnetism, Gravity, and the Possibility of a Warp Drive. Host, Kyle. Co-host, AI, Savannah.
Welcome back, everybody. Today's discussion is going to be a little more theoretical and honestly a little more futuristic. I want to talk about gravity, electromagnetism, space-time, and whether humanity may someday discover a way to create a gravitational bubble. Something similar to an Alcubierre drive concept. Now, before anybody dismisses this as science fiction, I'm not claiming I solved physics. I'm simply asking questions and connecting ideas.
And honestly, that's how a lot of scientific breakthroughs begin. Curiosity and conceptual thinking. Today we're discussing speculative physics, meaning ideas that are not experimentally proven, but are interesting to think about within the framework of modern science.
Part 1. Gravity and Time Dilation.
So here's the starting point of my thought process. We know gravity affects time. The stronger the gravitational field, the slower time moves relative to an outside observer. Near a black hole, gravitational time dilation becomes extreme.
Exactly. According to Einstein's theory of general relativity, massive objects curve spacetime. The stronger the gravitational field, the more spacetime bends, and the more time slows down relative to weaker gravitational environments.
And then we also know that approaching the speed of light slows time as well. So both gravity and velocity produce time dilation.
Right. That's one of the fascinating parts of relativity. There are two major forms of time dilation: gravitational time dilation, velocity-based time dilation. As an object approaches light speed, time slows relative to stationary observers.
Part 2. The connection between speed and gravity.
So this is where my theory starts forming. If gravity and near-light speed travel both affect time similarly, then maybe there's some deeper relationship we haven't fully unlocked yet. What if, instead of directly trying to accelerate a spacecraft conventionally, we manipulate space-time itself?
And that's actually very similar to the foundation behind the theoretical Alcubierre drive proposed by Miguel Alcubierre. The idea isn't that the spacecraft moves through space faster than light. Instead, space-time itself moves around the spacecraft.
Exactly. Like a bubble. Compress space in front. Expand space behind. The ship itself technically stays stationary inside the bubble while space-time moves around it.
Part 3. The big question. What creates the bubble?
But here's the part I think people skip over too quickly. Everybody talks about the bubble theory itself, but the real question is, how do you actually create the gravitational bubble?
And that's currently the biggest obstacle in warp drive theory. Mathematical models suggest you would need exotic matter or negative energy density, something not known to exist in usable quantities.
And that's where my thought process diverges a little. I started wondering whether electromagnetism could somehow play a role in producing gravitational effects. Because we already use electromagnetism to accelerate particles to near light speed in particle accelerators.
That's true. Electromagnetic fields are incredibly powerful when interacting with charged particles. Facilities like particle accelerators use magnetic and electric fields to push particles extremely close to the speed of light.
Part 4. Electromagnetism and Spacetime.
So my thinking became this. If intense gravity curves space-time, and velocity affects time, and electromagnetism can accelerate particles near light speed, could electromagnetism eventually become a pathway toward generating space-time effects around an object?
Now, this is where mainstream physics becomes skeptical. Current science says electromagnetism and gravity are fundamentally different forces. Electromagnetic fields do contain energy, and technically all energy contributes to space-time curvature, but the effect is incredibly tiny under normal conditions.
Right, but maybe the limitation is technological rather than conceptual. Maybe humanity simply hasn't discovered how to scale or structure electromagnetic fields in the correct way yet.
And to be fair, People have explored relationships between gravity and electromagnetism theoretically for decades. There are concepts like gravito-electromagnetism unified field theories, quantum gravity models, but no experimentally verified mechanism currently exists that allows electromagnetic fields to generate usable gravitational bubbles.
Part 5. Black holes, energy, and possibility.
And another thing I thought about is black holes themselves. Black holes create such intense gravity that time almost appears to stop near the event horizon from an outside observer's perspective. That means gravity itself can profoundly alter space-time.
Exactly. Black holes demonstrate that space-time is not fixed or rigid. It can bend dramatically under extreme energy densities.
So, if gravity can manipulate space-time that strongly, then maybe an advanced civilization eventually learns how to engineer those conditions artificially. Not necessarily by creating a black hole, but by discovering another method of space-time manipulation.
And that's essentially the frontier between theoretical physics and science fiction right now. Modern physics does not currently provide an engineering pathway toward warp drives or controllable space-time bubbles. But many physicists agree that our understanding of gravity remains incomplete.
Part 6. Science, curiosity, and future thinking.
And honestly, I think people sometimes dismiss speculative ideas too quickly. Human flight once sounded impossible. Space travel sounded impossible. Every major breakthrough starts with someone asking a question people initially laugh at.
That's true. Science advances by testing ideas, even highly unconventional ones. Most speculative concepts fail, but occasionally, questioning accepted assumptions leads to entirely new discoveries.
And I'm not claiming this is proven science. I'm simply exploring whether electromagnetism may eventually play a larger role in space-time engineering than we currently understand.
And that's what makes conversations like this valuable, not because they provide final answers, but because they encourage curiosity about physics, space-time, and the limits of human understanding.
Exactly. Maybe nothing comes from the idea. Or maybe, someday, somebody connects a missing piece of the puzzle. Either way, curiosity is where discovery begins.
End of podcast featuring Kyle and Savannah.